Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about compound inequalities, and we're going to solve each inequality and graph its solution. So if I was given this inequality, m minus 2 is less than negative 8, or m over 8 is greater than 1. Okay? So when I see that or, I have two separate inequalities I need to solve individually. So let's go do that. I'm going to add a 2 to both sides of this first one, leaving me an option that m is greater than negative 8 plus 2, which is a negative 6. Or, on this one here, I can multiply both sides by 8, leaving me with m by itself is greater than 8. So now I have two options here. So now I need to graph both of those options on one graph. My number line here. Now I want to make sure my number line covers both parts here. So I'm going to start with 0 in the middle. Just go by 2's, 2, 4, 6, 8, 10, and then negative 2, negative 4, negative 6, negative 8, and negative 10. Okay, so first one, m is less than a negative 6. So I'm going to take my open circle here, and negative 6 is not equal to negative 6, and I'm going to put my arrow to the left. Right, because we said m is less than negative 6. Then, from right here, this one, m is greater than 8. So I look at 8, I put an open circle as well, and put my arrow to the right. And now I have a graph that represents my compound inequality, which is m is less than negative 6, or m can be greater than 8. And so this graph shows now all possible values that m can be. Negative 1 is less than 9 plus n, which is less than 17. Okay? Well, my first step here is I want to simplify this, getting n by itself. So now n's in the middle here, right, between our two inequalities. So when I want to move the 9, I have to move the 9 to all parts. So if I subtract a 9 like this, I subtract a 9 over here and over there, okay, to all parts together, all right, all three parts. So negative 1 minus 9 is a negative 10. Still less than. What's left here is just my n is less than 17 minus 9, which is 8. So now we have this compound inequality of negative 10 is less than n, which is less than 8. So I can graph it now. N's isolated. So by graphing it, we want to make sure our number line encompasses up through negative 10 and 8, and usually I like to go a little bit past that. So let's go 0 here. Let's go at 2's. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Well, if negative 10, right, so here's the tricky part, right? If negative 10 is less than n, so that means n's going to be greater than negative 10, right? So if negative 10 is less than n, I take negative 10, and I'm going to put an open circle there, okay, right there at negative 10. Because it can't equal negative 10, but n is greater than that negative 10. We can see that, right? Negative 10 is less than n. So negative 10 is less than n, so n must be greater. So our arrow must be going to the right here. Up to a point where it says n is less than, though, 8. So 8 has to have an open circle as well. Okay? And n is less than that. So we bring up this arrow, the line, all the way up to 8. And there we have it. We have our graph here that matches our inequality. Because it says negative 10 is less than n, which is true, right? Negative 10 is less than n, it's not equal to. So n is all these values. All these values the line can work there, right? You know, negative 8 is greater than negative 10. And then kept on going here. And it's also less than 8, right? So we keep all these values in here are also less than 8, but not equal to 8. And so there we have it. We have our graph that matches our answer of negative 10 is less than n, which is less than 8. 2x is less than 10, or x over 2 is greater than or equal to 3. Okay? So 2x is less than 10, or x over 2 is greater than or equal to 3. I need to solve each inequality individually. So this one here, I'm going to divide by 2 to both sides, leaving me with x is less than 5. Or this one, I'm going to multiply both sides by 2, if I can fit that in there, leaving me with x is greater than or equal to 6. Okay? So now I have two inequalities here. I have an or separating them. Let's graph it. So we said x is less than 5, and x is greater than or equal to 6. So usually the two numbers that are there, I try to make sure my number line, my graph here, can handle those, right? Make sure you don't stop short of 5 or 6 there. So let's just go 0, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3. Okay? Well, the first one here, we said x is less than 5. So it's not equal to 5, so we have an open circle. And x is less than 5, so my arrow goes to the left. Fantastic. Then they said x is also greater than or equal to 6. So we look at 6, greater than or equal to, makes it a closed circle. And since x is greater than, put our arrow to the right. And there we have it. Our graph here matches our answer, because we said x is less than 5, but not equal to, open circle, and then x is greater than or equal to 6. Good. So there's only a little window of space that x cannot be between 5 and 6, and including 5, but not including 6. So this graph matches our final answer, which is x is less than 5, or x is greater than or equal to 6. X plus 8 is greater than or equal to 9, and x over 7 is less than or equal to 1. Okay? So let's go solve, they're separated, let's solve each inequality individually. So we're going to subtract an 8 to both sides here, leaving me with x is greater than or equal to 1. And, different than the or, multiply both sides by 7, leaving me x by itself is less than or equal to 7. Okay? So hopefully you can see this. We can see that there's going to be some overlap here where x is greater than or equal to 1 and x is less than or equal to 7. Okay? So let me graph that here. Okay? Well, if I graph this, okay, I'll put a 0 here. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, and -2. Okay. Well, we said that x is greater than or equal to 1. So we can equal 1 here, and we can shade to the right, right? Then they said x is also less than or equal to 7. So we have a closed circle at 7, and we shade to the left. Interesting. That means I can write this as one big inequality. All right. So the way I like to see it, if I flip this, instead of x is greater than or equal to 1, I wrote it as like 1. Little note here. Right. Same thing. 1 is less than or equal to x. Right. If I wrote that like this, so if I wrote 1 is less than or equal to x, I don't need the and anymore, because x then it kind of like morphs together to this one here. X is less than or equal to 7. And so now we have 1 is less than or equal to x, which is less than or equal to 7. And that actually means the same thing that's going on here, right? Because we want to have where both parts are true, right? Where x is greater than or equal to 1 and x is less than or equal to 7. So instead of doing my double arrows here, I'm going to erase that. And I'm going to graph it as just one solution, or one graph here. Closed circle at 1, that overlaps where both those lines overlap there, and a closed circle at 7. I connect them together, and there we go. We have the graph here that represents where 1 is less than or equal to, closed circle, x, in this range here, which is less than or equal to 7, closed circle right there. So now my graph matches my final answer, which is 1 is less than or equal to x, which is less than or equal to 7. -3 is less than or equal to p. I was running a 9 there. I guess I could have made it work, but p over 2 is less than 0. Okay? Well, what I want to do here is when I multiply by 2 to both sides, I isolate the p, I need to multiply 2 to all sides, all parts here. So to do that, multiply by 2 here, multiply by 2, and multiply by 2. In doing that, I'm left with p by itself in the middle. 0 times 2 is 0. And 2 times -3 is a -6. So fantastic. I have my compound inequality. Let's graph it right here. I'm going to make sure we go down to -6. So we have 0, -2, -4, -6, -8, -10, and 2, 4, 6. Okay. We start with the -6. -6 is less than or equal to p, meaning at -6 we have a closed circle. And then our arrow goes to the right. All right, our line goes to the right. We really don't have an arrow here. Until we hit 0, and then 0, it's an open circle, right? It's an open circle because it's not equal to 0. So we say that p is greater than or equal to, really, -6. Or -6 is less than or equal to p all the way up to 0. And then at 0, it stops. It's not equal to 0, and so that's why we do the open circle. So now we have a graph that matches our final answer, which is -6 is less than or equal to p, which is less than 0. R plus 5 is greater than or equal to 12, or R over 9 is less than 0. Okay? So now we want to solve each inequality individually. Okay, let's make sure I have everything. Good. So I'm going to subtract a 5 to both sides in this one, leaving me R by itself is greater than or equal to 12 minus 5, which is 7. Or this one here, I'm going to multiply 9 to both sides, leaving me R by itself, and 0 times 9 is 0. So now I have R is greater than or equal to 7, or R is less than 0. So when I make my number line here, I'm going to make sure I encompass both those numbers, 0 and 7. So let's put the 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and -1, -2. Okay. Well, they told us here that R is greater than or equal to 7. So I have a closed circle at 7. And so R can be greater than that, so I'm going to put my arrow to the right. The other one, what R could be, is R is less than 0, so it's not equal to 0, so I have an open circle at 0, and it's less than 0, so I have to put my arrow to the left. And there we have it. We have our graph here that represents our compound inequality, which is R is greater than or equal to 7, or R was less than 0. Okay? 7v is less than 5, which is, minus 5, not less than, is greater than or equal to 65, or -3v minus 2 is greater than or equal to -2. Okay? Again, with a separator, we need to solve each inequality individually. So I'm going to add a 5 to both sides here, giving me 7v is greater than or equal to 70. Then I'm going to divide by 7 to both sides, giving me v by myself is greater than or equal to 10. The ors keep coming down, or. So this one here, I'm going to solve it again. I'm going to add a 2 to both sides, leaving me -3v is greater than or equal to a 0. Okay, -2 plus 2 is 0. Then I'm going to divide by -3, and since I'm dividing by a negative over inequality, the inequality flips. So we're left with v here is less than or equal to 0 divided by -3, which is 0. Okay? Important right there, right? Greater than or equal to turns into a less than or equal to, because we're divided by a negative. But now I have my two inequalities, so I can graph it. So let's make a little number line here. Let's go 0, 5, 10, 15, and -5. Okay? Well, they told us that v is greater than or equal to 10. So I have a closed circle at 10, closed circle at 10, and v is greater than that, so I put my arrow to the right. The other one here says v is less than or equal to 0. So again, at 0, I have a closed circle. And I put my arrow to the left, showing that v is less than 0. And now we have it. We have our graph here that matches our compound inequality, which is v is greater than or equal to 10, or v is less than or equal to 0. -10b plus 3 is less than or equal to -37, or the inequality 3b minus 10 is less than or equal to -25. Okay? My first step is I need to solve both inequalities individually. So I'm going to subtract a 3 to both sides here. On the first one, leave me with a -10b is less than or equal to -37 minus 3 is a -40. Now I need to divide by -10 to both sides. And remember, when we divide by negative over the inequality, that inequality flips. So we're left with the b on the left is greater than or equal to now -40 divided by -10 is a +4. So now I need to solve the other one, because this one's all done. I add a 10 to both sides here, leaving me with a 3b is less than or equal to -25 plus 10 is a -15. I then divide by 3 to both sides, leave me with b is less than or equal to -15 divided by 3 is a -5. So our options were or. So now we have b can be greater than or equal to 4, or b can be less than or equal to -5. So now let's graph it. Okay? So let's put 0 in the middle. Let's go 1, 2, 3, 4, 5, 6, 7. -1, -2, -3, -4, -5, -6, -7. Okay? Well, if b is greater than or equal to 4, I have a closed circle at 4, so I'm going to put my closed circle right there. And since b can be greater than 4 also, I need to put my arrow to the right. And there we have our graph that represents b is greater than or equal to 4. But we have another part where it says b is less than or equal to -5. So since it can equal -5, I have a closed circle right here at -5. And then it says b is less than -5, so I'm going to put my arrow to the left. And so now I have a graph that matches my inequalities here, that b is greater than or equal to 4, or b is less than or equal to -5. -1 plus 5n is greater than -26, and 7n minus 2 is less than or equal to 12. My first step here is I want to solve each inequality individually. So I'm going to add a 1 on both sides for this first one, leaving me with 5n is greater than a -25, right? Because -26 plus 1 is -25. And I divide it by 5 on both sides, giving me n by itself here is greater than -25 divided by 5 is a -5. Okay? So now I'm going to solve this one. I add a 2 to both sides, leaving me with 7n is less than or equal to 12 plus 2, which is 14. And then divide by 7 on both sides, giving me n by itself is less than or equal to 2. 14 divided by 7. Okay? So now this one's tricky. We're given and here, and we're given a range. We said n has to be greater than -5, and n is also less than or equal to 2. I'm going to see if I can combine this into one statement. Okay? So I'm actually going to flip this one right here to have -5 come first, then is less than n, right? Because n being greater than -5 is the same thing as -5 is less than n. And then if I combine these two right here, that n together, see what I'm doing? I have a less than or equal to a 2. So now these two statements can come together and be combined into one big statement here. Okay, because let's look, is anything false here? Where n is greater than -5, that's shown right here because -5 is less than n, same thing. And then n also has to be less than or equal to 2, okay? So we have to have both of these things occur, all right? So now we have our one statement. I can graph that, okay? So let's go 0, -1, -2, -3, -4, -5, -6, -7, and then 1, 2, 3, 4, 5, okay? Well, a -5 is less than n. It's not equal to n, but it's less than n. So we're going to put an open circle there, all right? And then at 2, we said it can equal to, so I'm going to put a closed circle there. And then n exists between those two. So I'll put my bar or my line that goes between them right there. And there we have it. Our graph here represents all the values that n can be, which are -5 is less than n, which is less or equal to 2. -50 is less than 7k plus 6, which is less than -8. Okay? Well, first thing I'm going to do is I'm going to subtract a 6. And when I subtract a 6, I'm going to subtract it to all parts. Okay? On the outside as well as the inside. That leaves me with 7k in the middle. And then -50 minus 6 here is -56. And that's still less than. And then less than -8 minus 6 is a -14. Okay? And so now what I need to do, okay, is I'm going to divide by 7. I'm going to divide by 7 to all parts as well. Okay? -56 divided by 7 is a -8. That's less than k, which is by itself here, which is less than -14 divided by 7 is a -2. Okay? So now we have -8 is less than k, which is less than -2. Fantastic. That's our final answer. But now I need to graph that solution. Okay? So I'll put a little graph down here. Let's go by 2. So let's start at -12. -12, -10, -8, -6, -4, -2, 0, -0, 2, 4, 6. Okay? Well, -8 is less than k, which is less than -2. It can't equal -8, so I'm going to put an open circle there, -8. And it's not equal to -2, so I'm going to open circle at -2. So now k can exist between them. I put my line between there, and there we have it. Our graph here matches our final answer, which is -8 is less than k, which is less than -2. 8x plus 8 is greater than or equal to -64, and negative 7 minus 8x is greater than or equal to negative 79. Okay? Well, our first step here is I'm going to solve each inequality individually. So I'm going to subtract an 8 to both sides here, giving me 8x is greater than or equal to negative 64 minus an 8 comes out to be a negative 72. Okay? Then I want to divide by 8 to both sides. And when I divide by 8 to both sides, x is by itself here, is greater than or equal to negative 72 divided by 8 is a negative 9. So now I need to solve this one. I'm going to add a 7 to both sides. By adding a 7 to both sides, I'm left with negative 8x is greater than or equal to negative 79 plus 7 is negative 72. I then need to divide by negative 8 to both sides. Divided by negative 8 to both sides gives me x by itself here. But since I'm dividing by negative over the inequality, that greater than or equal to sign turns into a less than or equal to sign. So we have less than or equal to there. And negative 72 divided by negative 8 is a positive 9. And again, our answer is and. It's this and that. X is greater than or equal to negative 9, and x is less than or equal to 9. So I'm going to flip this one over, the smaller one, or not really smaller, to one that starts with a negative 9, and x is greater than that. Okay? I'm going to flip it where negative 9 comes first, and that's less than or equal to x. These two statements are the same. X is greater than or equal to negative 9. Negative 9 is less than or equal to x. But now we can combine it because we said x has to be this and that. X has to be, or negative 9 has to be less than or equal to x, and x has to be less than or equal to 9. So I can kind of toss this down here, giving me less than or equal to 9. And there we have it. I have my compound inequality combining the two parts here, that negative 9 is less than or equal to x, which is less than or equal to 9. So now, let's graph it. Okay? Let's go by 3's. 3, 6, 9, 12. Negative 3, negative 6, negative 9, negative 12. Okay? Well, we start at negative 9, and x can equal negative 9, so I'm going to put a closed circle right there. X can also equal positive 9, so I'm going to put a closed circle right there as well. And x can exist everywhere in between. So I'm going to draw a line between negative 9 and positive 9. And there we have it. We have our graph here that matches our final answer, which is negative 9 is less than or equal to x, which is less than or equal to positive 9. 2n plus 7 is greater than or equal to 27, or 3 plus 3n is less than or equal to 30. Okay? Well, first thing, I need to solve each inequality individually. So I'm going to subtract a 7 to both sides here, leaving me with 2n here is greater than or equal to 27 minus 7 is 20. I then divide by 2 to both sides, giving me n by itself is greater than or equal to 10. Or, solve the other one, I subtracted 3 to both sides, giving me 3n is less than or equal to 27. I then divided by 3 to both sides here, giving me n is less than or equal to 27 divided by 3 being 9. So now I have my two parts. N is greater than or equal to 10, or n is less than or equal to 9. Okay, we have our two ors here, our two possibilities. So I need to graph them. So let's go to the number line here. Let's go put 0 right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And really don't care what's going on here. But negative 1, negative 2. Probably could have made it a little better, but it's all good. So we said n is greater than or equal to 10. Well, at 10, it can equal 10, so let's put a closed circle right there at 10. And since n is greater than also 10, I'll put an arrow to the right. Next one, n is less than or equal to 9. Well, it can equal 9, so I'll put a closed circle right there at 9. And it's less than, I put my arrow to the left. And there we have it. We have our graph here that matches our final answer, our compound inequality of n is greater than or equal to 10, or n is less than or equal to 9. Negative 36 is less than 3p minus 6, which is less than negative 15. Okay? Well, my first step is I'm going to add a 6. And when I add a 6, I'm not going to just do both sides, but all sides. So I'm going to add a 6 here, and I'm going to add a 6 here as well. Negative 36 plus 6 is a negative 30. And that's less than whatever's on the inside, which is 3p now, which is less than negative 15 plus 6, which is negative 9. So now I have 3 times p. Opposite multiplication is division. So I'm going to divide by 3 on both sides. or all sides, not just both sides, all three sides, right? And in doing that, I have p by itself in the middle. Negative 9 divided by 3 is a negative 3, and negative 30 divided by 3 is negative 10. And there we have it. We have our final inequality. Negative 10 is less than p, which is less than negative 3. So now we need to graph that. Okay? So in graphing that, let's start here. Let's put negative 10 right there. And let's go by 1. So negative 11, negative 12. And then we have negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Okay? Well, since negative 10 is less than p, it's not equal to p, I have an open circle at negative 10. Then at negative 3, right, p cannot equal negative 3, so I'm going to have an open circle at negative 3. But p exists in between negative 10 and negative 3. So I'm going to put my line here in between them. If I can paint a straight line, it's a little harder than it looks, folks. Okay? So we have our graph here from negative 10 to negative 3, not including those values, but p can exist ever in between. And that graph matches our final answer, which is negative 10 is less than p, which is less than a negative 3. Negative 1 minus 10a is less than negative 1, or 10 plus 3a is less than or equal to negative 5. Okay? Well, our first step here is I'm going to solve each inequality individually. So I'm going to add a 1 to both sides here, giving me a negative 10a is less than negative 1 plus 1 is 0. I then am going to divide by negative 10 to both sides. That leaves me a by itself, but I'm dividing by a negative over an inequality. That less than sign turns to a greater than sign. And 0 divided by negative 10 is 0. Okay? So now I'm going to solve this one. I'm going to subtract a 10 to both sides, giving me 3a here is less than or equal to negative 5 minus 10 is a negative 15. And then I'm going to divide by 3 to both sides, leaving me a by itself is less than or equal to negative 15 divided by 3 being a negative 5. So now I have my two parts. I have a is greater than 0, or a can be less than or equal to negative 5. So now we need to graph that. Okay? I want to make sure I have 0 and negative 5 in my number line here. Put 0 here. And then let's go by ones. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. It's not that even. Sorry. Negative 7. Not really. Sorry. 1, 2, 3, 4. Okay. So we said a can be greater than 0. So in 0, we have an open circle. And because a is not equal to 0, it's just greater than, and I'm going to put my arrow to the right. Okay? Then they also tell us that a is less than or equal to negative 5. Since it can equal negative 5, I have a closed circle there. And since it's less than, I'm going to put my arrow to the left. Right there. So now my graph here have my two parts, matches my or statement above, which is a is greater than 0, or a is less than or equal to a negative 5. 3n plus 2 is less than a negative 2 plus 7n, or 8n minus 4 is less than or equal to 3n minus 4. Okay? Well, my first step here, I'm going to solve both individually. So I'm going to subtract a 7n to both sides here, and I'm going to subtract a 2 to both sides. So we're going to n to the left, numbers to the right. 3n minus 7n is negative 4n, is less than negative 2 minus 2 is negative 4. I then need to divide by negative 4 to both sides. And in doing so, negative 4 to both sides, I'm left with n here. And since I divided by a negative over the inequality, okay, that flips the inequality from a less than to a greater than sign, and negative 4 divided by negative 4 is a positive 1. So now I have n isolated. I got to solve this one. So I'm going to subtract a 3n to both sides. I'm going to add a 4 to both sides. Giving me 8n minus 3n is 5n. Is less than or equal to negative 4 plus 4 is 0. Now I need to divide by 5 to both sides. And divided by 5 to both sides, I'm left with n by itself here is less than or equal to 0 divided by 5 is 0. So now I have n is greater than 1, or n is less than or equal to 0. So now I need to graph that. So let's get my number line right here. Okay, I have 0, 1, 2, 3, 4. and -1, -2, and -3 kind of fit in there. Okay. Well, since n is greater than 1, it's not equal to 1, just greater than 1, I have an open circle at 1. Then I put my arrow to the right because n is greater than that 1. Then the next one here, we said n is less than or equal to 0. Since it can equal 0, I put a closed circle right there at 0. And I put my arrow to the left because n is also less than 0. So now we have our graph here that matches our inequalities, where our graph here matches the inequality of n is greater than 1 or n is less than or equal to 0. 8r minus 5 is greater than or equal to 6r minus 1, or 4 plus 4r is less than or equal to 3r minus 3. Okay? Well, my first step is I'm going to solve each individually. So I'm going to subtract a 6r to both sides here, and I'm going to add a 5 to both sides. And in doing so, 8r minus 6r is 2r, and that's greater than or equal to -1 plus 5 is a positive 4. And then I'm going to divide by 2 to both sides, giving me r by itself is greater than or equal to 4 divided by 2, which is 2. So now I'm the same thing here. I'm going to subtract a 3r to both sides, and I'm subtract a 4 to both sides as well. 4r minus 3r is just 1r, and it's less than or equal to -3 minus 4 is -7. So I'm going to rewrite that down here, or kind of bring it down. R is less than or equal to -7, so they're on the same level. Both my r's are isolated. Fantastic. So now I need to graph them. So I draw my number line here. Okay. I'm going to include -7, and so -8 here, -9, -6, -5, -4, -3, -2, -1, 0, 1, 2, and we put 3 in here. Okay. Well, first one here, we said r is greater than or equal to 2. So I have a closed circle at 2 because it can equal 2. And r is also greater than 2, so I put my arrow to the right. Okay. The next one, r is less than or equal to -7. So at -7, it can equal -7. So I have a closed circle at -7. And I put my arrow to the left because r is also less than that -7. It doesn't need to go down, but it's just less than, okay? I'll fix it a little bit. It looks a little, there's a thick one. There we go. Okay, whatever. There's my arrow. Don't judge me. Okay? So now my graph matches my final answer, which is r is greater than or equal to 2, or r is less than or equal to -7. 5x minus 5 is greater than -7x minus 5, or 3x plus 5 is less than or equal to x minus 1. Well, my first goal is I'm going to solve each individually, so I'm going to solve this one first. I'm going to add a 7x to both sides, and I'm going to add a 5 to both sides as well. 5x plus 7x is a 12x. It's greater than. -5 plus 5 is 0. Well, if I divide by 12 to both sides here, 0 divided by 12 is 0, and we're left with just an x on the left. So now I need to solve this one on the right. So I have a negative x, or so I'm going to subtract the x to both sides, and I'm subtract a 5 to both sides. Let's bring our x's to the left, numbers to the right. 3x minus x is a 2x, is less than or equal to -1 minus 5 is a -6. From there, I'm going to divide by 2 to both sides there, leaving me x by itself here is less than or equal to -6 divided by 2 is a -3. That's an or statement between them, so if x is greater than 0 or x is less than or equal to a -3. So now I need to graph them. Okay? Here, let's go by ones. 1, 2, 3, 4, 5, -1, -2, -3. And let's increase that a little bit. Here, that's a -4 and a -5. Okay? Kind of made it a little tight there. Okay? So x is greater than 0. So x is greater than 0, so I'm going to open circle at 0 because it's not equal to 0. X is greater than, so I shade to the right. Then this one, x is less than or equal to -3. Since it can equal -3, I have a closed circle. And since it's less than, I put my arrow to the left. And so now I have my graph that matches my final answer, which is x is greater than 0 or x is less than or equal to a -3. 6 plus 7m is less than 6m minus 5. Or 3m minus 7 is less than 5 plus 6m. Okay? Well, the first step, I'm going to solve each individually. So I'm going to subtract a 6m to both sides, and I'm going to subtract a 6 to both sides, leaving me just 7m minus 6m, which is 1m, is less than negative 5 minus 6 is negative 11. This one here I need to simplify now, or solve. Excuse me. So I'm going to subtract a 6m to both sides, and I'm going to add a 7 to both sides. And in doing so, 3m minus 6m is a negative 3m, and that's less than 5 plus 7, which is 11, or 12. Can I add? Can I even add? No. So I divide by negative 3 to both sides here, given m now by itself, and my less than sign turns into a greater than sign because I divide by a negative over the inequality. So I have m is greater than negative 12 divided by negative 3 is negative 4. So this is an OR statement. Let's go rewrite it together. All is one big OR statement. So m is less than negative 11, or m is greater than negative 4. Okay? So now I want to graph this. So a little number line here. Let's go negative 13, negative 12, negative 11, negative 10, negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, they're getting smaller, negative 2. Okay. So m can be less than a negative 11. It's not equal to negative 11, just less than. So I have an open circle there at negative 11, and then my arrow goes to the left because m is less than that. Negative 4. M does not equal negative 4, but it's just greater than. So I have an open circle at negative 4, and I put my arrow to the right because m can be greater than that negative 4. So now I have my graph here that matches my final answer, which is m is less than negative 11, or m is greater than negative 4.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.